All right, Chapter 6, Section 3, Logarithms and Logarithmic Functions. A logarithm, okay? You know that 2 squared is 4, 2 to the third is 8. However, for what value of x does 2 to the x equal 6? Mathematicians define this x value using a logarithm and write it as x equals log base 2 of 6. The definition of a logarithm can be generalized as follows. So you got all of this mathy stuff. But this is important, especially this part right here and this part right here. Let b and y be positive real numbers, and b is not a 1. The logarithm of y with base b is denoted by log base b of y and is defined as log base b of y equals x if and only if b to the x equals y. The expression log base b of y is read as log base b of y. The little b at the bottom is the base b. Log of whatever base of whatever number or letter for that matter. This is a pretty interesting deal because they say log base b of y equals x and then b to the x equals y. Notice they all have a y. They all have an x, and they all have a b. It's just where they are and which side they're on. When it's in log form, the b is on the base, and it's of y, and it equals x. But in exponent form, the base of the exponent is the b to the x. It's been moved into the exponent zone, and then it is equal to y. It is almost like if we had... wrong pen. Log y equals, and then we're going to go, there's a base b, and then there's an x. It's almost as if you take the, nope, I want, not what I wanted. If you take the b and you just slide it over here, and then you get rid of that part. B to the x equals y, or if you take the b back, log base b of y equals x. So basically all I end up doing when I switch these is I just move the b here or move the b back, and it becomes the base. The base is always the base. It's either the base of the exponent or the base of the log. So let's look at some examples. We're going to rewrite each of these in exponential form. So when we have log base 2 of 16 equals 4, we take the 2, we drag it over here, and it's 16 equals 2 to the 4th. The 4 shifts up, the 2 becomes the base. If it's the base of the log, it's the base of the exponent. And that actually works because 16 is equal to 2 to the 4 because 2 to the 4 is 16. Take the 4, drag it over, it becomes the base, leave the 1, the log drops, 4 becomes the base, 0 moves up into the exponent spot, and anything to the 0 is 1. That checks out. So we got this, we got that. Take the 12 over, 12 equals 12 to the first. Yeah, because 12 equals 12. 1/4, 4 is left behind. The 1/4 moves over, becomes the base. The exponent is negative. Okay, and the negative exponent means we flip the reciprocal of this. So we do 4 equals 4, and it does. Okay. So just slide the base of the log over as the base of the exponent. What is already on the other side of the equals jumps up into the exponent spot. We can also do this in reverse. If it is an exponential, we can write it as a log. Take the base, move it back over, add the log base 5 of 25. Take the 10, move it over, -1 equals log base 10 of 0.1. Take the 8, move it over, 2/3 equals log base 8 of 4. The base is the base. Move it over. -3 equals log base 6 of 216. That's all it takes. Now, evaluating. If possible, you can evaluate it by hand or mentally, or you may need to use a calculator. But let's see if we can find some of these mentally first. Now, it's way easier to just type them in the calculator if it'll do it. But if you don't have one and you need to try, here's something you can do. Take the problem, like problem A here, log base 4 of 64. If we want to know what that equals, we say, well, it equals what? Well, I don't know. So when I don't know, I put a variable. Then I'm going to move this over here. So 64 equals 4 to the x. Or 64, what? 4 to the what number is 64? Well, 4 times 4 is 16, times 4 is 64. Look at that. So it's actually, if we rewrite this as 4 to the third equals 4 to the x, if they have the same base, we can drop the base, and it's just x equals 3. So that means it would be 3. We can do the same thing over here, but instead of a decimal, I'm going to do it as a fraction. That's 2/10. Or in other words, it's 1/5. So if I move this over, 1/5 equals 5. That's a weird 5. 5 to the x. What number do I raise the 5 to turn it into a 1/5? Well, what I notice about 5 and 1/5 is the 5's at the bottom instead of the top. So I want to flip it over. I want to reciprocal it. That means I need to do a negative exponent. So that's what x is going to be, -1. 5 to the -1 is 1/5, which is 0.2. Same thing here. We got 125 equals 1/5 to the x. Well, number one, I need the 5 to get in the top. So I know that x is going to be a negative number. And then I needed to get to 125. So it's not just to the first, but to the second is 25. To the third is 125. So x is a -3. And log base 36 is 6. 36 to the what is 6? Well, 6 is 36 to the what? Well, I need to get smaller. So it can't be a whole number. Because 1 is 36, 2 is going to be even bigger than that. I need to shrink it down. And I know 6 and 36 are related because 6 times 6 is 36, and that's a square. So really the square root of 36, which is, square root is the same thing as to the 1/2. So I need 1/2. Okay, 0.5 if you did it on a calculator. Now, there are something called the common log and then the natural log. These are the ones that are on your calculator mainly. So if we pull up our big yellow calc, okay, when you see the log button right there or the ln button right there, those are referring to the common log and the natural log. And if you'll notice the buttons, they have their inverses, they have their opposites on the same button as the second feature. And that will help you remind you of what the common log and the natural log are. The natural log goes with the natural number, e. But the common log is not one that you would know unless we told you. But it's base 10. And it's denoted as log base 10 or simply just log. You don't actually have to write the base. If you do, it doesn't hurt. But if you see just log of x, they mean log base 10 of x. And if you see ln of x, that's log of natural. Okay, so that's the natural log or log base e of x. You'll need to memorize those and know them. So on A, when it says evaluate log base 8, and we're going to use a calculator and round, we're just going to use that log button. So I'm just going to push log of 8, boink, and that's approximately 0.90, what did it tell us to round to? 3 decimal places. 903. 0.903. Now let's look at B. We're supposed to do the ln of 0.3. So now I just go clear. I do ln of 0.3. And that's negative 1.204 when I round to 3 decimal places. Okay, so those would be my answers if I typed them in to the calculator like that. Now, big yellow calculator or the graphing calculator, TI-84, doesn't do the logs as easily because the log button that's on here is only log base 10. And we'll get to how to deal with that later on as we go. If you're using Desmos as your calculator, it's a little easier because if you do a functions, we go into the MISC, there is a log button, but then there's also a log and a variable base button. So you can actually do log of any base. It automatically changes the base from log base 10 to whatever base you need it to be. So I would use the Desmos calculator over the big graphing calculator. They're both easy, and I'll show you both, but Desmos works a little easier. Okay. So rewrite the equation in exponential form, and then rewrite the equation in log form, and then evaluate. Round if necessary. So I'll show you how to do those. It's going to be round if necessary is going to be 11 and 12 because we don't know how to do log base 2 and log base 27 yet, really, even though Desmos will do it. But give it a pause, try these 12, come back, see how you go. All right, let's give it a go. Grab the base, move it over. 81 equals 3 to the 4th. Grab the base, move it over. 7 equals 7 to the 1st. Grab the base, move it over. 1 equals 14 to the 0. Grab the base, move it over. 32 equals 1/2 to the negative 5. Same thing with backwards. Grab the base, move it over. 2 equals log base 7 of 49. Grab the base, move it over. 0 equals log base 50 to the 1st. Grab the base, move it over. Negative 1 equals log base 4, 1/4. Grab the base, move it over. 1/8 equals log base 256 to the 2. Or of 2. It's that simple. It's that easy. Log base 2 of 32, let's see, well, equals x, move it over. 32 equals 2 to the what? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so x is 5. Move it over. 3 equals 27 to the what? That should have been a question mark, but it needs to be an x. Well, 3 times 3 is 9, times 3 is 27, so x is 3. Now log base 12, that's real easy. All I got to do is go in here to funcs, do log of 12, 1.079. 1.079, approximately, remember. And then we got to do a natural log, so let's clear that one out. Funcs. We got an ln in there somewhere. Boom, there's one. ln of, what are we doing? 0.75. So that's about negative 0.288, rounded to 3 decimal places. Okay, and that's what it looks like. You could do it on the TI-83 as well, or other calculators. Now, some very important pieces of information are these guys right here and right here. Inverses. We talked about these, things that undo each other. Add and subtract, multiply, divide, square, square root, radical, and the root. But we've also got exponential form and log form. That's why we learn these back to back. Exponents we just talked about in the last 2 sections. Now we're learning logs. They're inverses of each other. If you take the log base of the same base exponent, it is just the exponential piece. The log base b cancels out. If you do an exponent to a log of the same base of a thing, the exponent base and the log base cancel out. The bases can cancel each other if they're the same bases and they're to this. So log base b of b to the x, the log base b and b cancels. They're inverses, undoes each other, leaves you with x. B to the log base b of x, the b and the log base b cancels. They undo each other. So, it says simplify a, 10 log of 4. Well, remember that when we're looking at a, 10 to the log of 4 is log base 10 of 4. Those are the same, so it's just 4. If we do log base 5 of 25 to the x, no, those aren't a match. But remember, we can write 25 is 5 squared to the x. The log base 5 and 5 go away. And when you have an exponent to an exponent, you multiply, so that's just 2x, right? So that would be log base 5 of 5 to the 2x. Those drop. leaves you with 2x. So find the inverse of each function. When we find the inverse, we switch the x and the y. Remember, don't treat it as this, treat it as that. And then say x equals 6 to the y, and then get y by itself. So we're going to move the 6 over. The base of the exponent becomes the base of the log. So log base 6 of x equals y. That's the inverse. Even with natural log, it's the same thing. If I switch the x and the y, so x equals the ln of y plus 3, I'm going to move the ln. Remember that is a log base e, right? Log base e. So when I move it, it becomes e to the x equals y plus 3. Then get rid of your plus 3. E to the x minus 3 equals y. There's your inverse. Just like that. Here's something to try. Simplify the expressions as best you can. Using those last little things we learned about them canceling each other out being inverses. Pause, try them, come back, see what you did. All right, here we go. 13. Base 8 to the log base 8, those cancel, leaves you with x. Cancel, leaves you with negative 3x. Now, the 15, that one's we actually have to do a little bit on. Log base 2 of 64. Well, I want it to be a 2 to the something. And let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th to the x. So that's log base 2 to the 2 of 2 to the 6x. Those drop. It's just 6x. 16, e to the ln. E and ln are opposites, so it's just 20. Find the inverse. All right, so let's look at 17. We're going to switch the x and y. X equals 4 to the y. I want to get the y out of the exponent spot, so turn it into a log. Base of the exponent becomes the base of the log. Log base 4 of x equals y. And 18, find the inverse. Switch the x and y. ln is e, so when I move it from log base, remember this is log base e, when I move the base over, it becomes the base of the exponent. And then get rid of your 5. So e to the x plus 5 is your inverse. Then it gets into graphing, and you can use that inverse relationship between exponential and logarithm forms to graph logs, okay? And it just talks about the different graphs. The graph of log base b of x, when b is greater than 1, it's going to look like the opposite or the inverse across that y equals x line, that identity line. Okay, it starts really close to 0 and then forever gets bigger and bigger and bigger. Same thing with log base b of the x. Whenever b is between 0 and 1, it's going to be a decline situation. So this is going to be like a growth, and this is going to be a decay. Kinda. Those are what they're related to. Anyway, remember that thing with graphing on these. If the exponent has a base that is bigger than 1, it's growth. If it's between 0 and 1, a fraction, it's a decay. It's getting smaller by that amount each time. There is an asymptote that you have to deal with, just like the others. All right, so this asks you to graph it. All I would tell you to do is put it in the old calculator. So y equals, now here I do that log of a, log base a. This is kind of a cheat mode for us. So our base is a 3, and then we're going to do of x. And it gives us a nice graph there. Now in your TI-84s, it's not going to do that for you. You have to do something else to it before you can actually type it in the TI-84 calculator. So I would use Desmos on this. Otherwise, you're going to use what they want you to do, which is they're going to say, okay, we'll change it. Move it over here and say 3 to the y equals x. And so if you do 3 to the y equals x, there you get your graph. Okay? Same as your inverses. Now if you flipped them and you did y equals 3 to the x, there's your inverse. And all you'd have to do is get your chart of those, and you could switch your x and y's, and that would be the x and y's you need for the inverse piece. Okay? Because you can't actually graph 3y equals x on the TI-84. You'd have to graph the y equals 3 to the x. And then all of its xy coordinates, you'd get a little chart, right? You just switch them. and that's going to be your inverse, because when we inverse, we switch x and y. And that's how you graph them. So you can give it a try, graph these, see what you get. I'll show you pictures of them. So pause it, make sure you can type it into Desmos or the other calculator pretty good. All right, here we go. I'm going to use this calculator because it's the easier one. Y equals functions log base 2 of x. That's the graph you should get. And then we got y equals log base 5 of x. That's the graph you should get. They kind of look the same. Hard to tell the difference. And the last one, if I can move the graph, we got y equals log base 1/2. Oop. So here's how we solve that problem. Equals log, let's do parenthesis. I know what we're going to do. It doesn't like fractions down there. Log 0.5 of x. Notice that the b, the base changed. It's a fractional b, which means it's going to be a decay, so it's counting down, starts really high, gets low and closer to an asymptote there. Our asymptote is really, really close to -2, but not. Okay, works just like that. If you're going to do that on the TI-84, I'll show you real quick. So what I would do, especially with this other one, right? I'd switch my x and y. So I get x equals log of the 1/2 y, and then I move this over. So it's 1/2 to the x equals y. That's what I can type in my y equals. Y1 is 1/2, and then we're going to go to the x, and then we're going to do graph. Okay. Zoom 6, that's my favorite, zoom standard. All right, and then what we can do is we can go to the table and we can look at the XY chart, and I would get a chart of X's and Y's. And what I'm going to do is I'm going to switch them. Okay, so let's see, let's go -2, -1, 0, 1, and 2. So at -2, it's 4. At -1, it's 2. At 0, it's 1. At 1, it's 0.5. At 2, it's 0.25. So what I need is to switch those. My x and my y are going to be 4, -2, 2, -1, 1, 0, 0.5, 1, 0.25, 2, and I can graph my graph that way. Put all the pieces together. It's a little harder with the TI-84 because of that function. There are some ways around that. There we go. In the math button, you can do log base, which does a log base change there. So we can actually do log base 1/2, and let's see, what is it, to the x? And you can do that. Of course, it tells me nothing, but we can put in different log bases. It does have a change of base formula inside here. There's also a formula